So compared to organic side, inorganic pollutants are those pollutants that do not contain carbon. Now, in this case, most of the time we are referring to pollutants such as metals. So you know what is heavy metals, right? Now, before I begin, heavy metals is a term given to a metal-based contaminant, which is usually having a very high atomic number. So that is why they are called heavy metals. But to be more accurate, heavy metals is mistakenly used for any elements that are toxic in the environment. That also have been mistaken with inorganic contaminants or inorganic pollutants such as chromium. I'm sure you know what is chromium. Now, chromium is not really a metal. We usually refer, in chemistry, we refer chromium as a metalloid. That means an element that is neither metal nor non-metal. They have a little bit of both characteristic. Similarly to arsenic. Arsenic also is not considered as metal. It's called a metalloid, which is why, to be more accurate, in the inorganic pollutants, usually we call toxic elements. Yeah, toxic elements in the environment. Because if you say elements, that also covers metalloid as well as metal, in which you won't go wrong instead of calling them heavy metals. So yeah, with that, I will going to continue uh, with the lecture. So these are the examples of inorganic pollutant. I'm sure what you know about mercury, but most of you don't know mercury actually is more deadly in gas form, not in it's Hg2 plus form. Hg2 plus, you can find it in soil, more so in water. They may dissolve in water. But not a lot of people know that mercury kills a lot of people from gas phase. So we will discuss later. Yeah. Cadmium, you can find it mostly in electronics, previously used as rechargeable batteries. Lead, I'm sure you know what is that. Lead, I did a lot of research. I do a lot of research on lead. And most of the time is due to firearms. Yeah, bullets. Bullets, for example. Bullets, I can tell you that 95 to 99% of bullets produced in the world use lead. Why lead? Because lead is heavy. Not because they're toxic. People don't know they're toxic, but lead actually is quite heavy. So when it is fires and discharged from a firearm, it carries a lot of momentum. So when it hits a target, it penetrates and go through, which means that it's good yeah. There are other elements that can be used, but usually it's lead in this case. A part of it is arsenic. So like I told you just now, arsenic is not a metal. It is an element. And then more specifically is a metalloid. Arsenic, where can you find it? Okay, it's already in the soil. Now, not many people know arsenic is already in the soil until it's too late. Example, remember the small mining activity in Pahang last time about rare earth, not rare earth, I think bauxite mining in Pahang. When that happened, suddenly all groundwater in Pahang has an elevated level of arsenic. There's a story because not soil created the same as we've learned before and coincidentally Pahang soil consists of a lot of arsenopyrite. Arseno means they contain arsenic. Pyrite means there's a mineral that contains primarily iron and also sulfur. So when oxidized, they will be released. Nickel is not really a big issue in Malaysia, except that if it's in an industrialized area, yeah, depends on what industry that uses nickel and how they manage nickel waste. Copper is very common as well as zinc, because copper and zinc, believe it or not, is already in human waste. Our human waste, IWK, reported that two of the highest toxic element is copper and zinc, believe it or not. But the good thing is copper and zinc at a certain level, it can be a nutrient for plants. Too high, it is still toxic. Now, chromium, like I told you just now, is also a metalloid. And it is mostly contained in industrialized area in the what we call chroming process. The chroming process where you coated a surface with chrome or metallic finish. So they use a lot of chromium. Molybdenum, I'm not so sure because Actually, molybdenum is a trace nutrient, a nutrient that's needed by plants. For somehow is inorganic pollutants here for not sure, but maybe you can Google later like what molybdenum can do and harm the environment. Selenium is the same. Fluorine is also, but these, I mean, the bottom three, they are, I think, selenium and molybdenum, chromium, molybdenum, and selenium. They are oxy metals, which is not really a metal. Again, chromium, molybdenum, and selenium, they are most likely considered as metalloid. Whereas the bottom two, fluorine is a non-metal, as halogen, fluorine. Boron is a metalloid as well. So you can see, although the whole list consists majority of metal-based pollutant, quite a number of this list consists of metalloid. So that's why you have to be careful when it comes to using terms such as heavy metals. Yeah? Now, I will not going to go through one by one lah. What are these heavy metal? What are these elements? And then what they do and how they harm human health. So I guess you go through by yourself lah. I won't going to like explain so much. And I think I'm going to skip through. So you can spend your time and read it. However, I'm going to stop a bit here to discuss about how inorganic chemicals gets into our food chain and ends up harming us in this part, the end. Now you can say moving from left to right, you are actually going up the food chain from left to right. Usually the food chain is triangle. You start from bottom and you move up, isn't it? So this diagram is a bit uh, it's a bit different than the triangle that you see. It has been like turned 90 degrees. So the top of the food chain is right here, human. We are considered at the apex predator in the food chain because we can eat everything, although we don't, but we can. And then most of the bottom feeders, I mean, at the bottom of the food chain lies on here. So it begins with the source of the pollution. So as you can see, most of these inorganic chemicals or inorganic contaminants started from the industry, usually human activities lah. But you cannot say all human activities because, like I said to you just now, arsenic, a contaminant, already in the soil. So some of the rocks in Malaysia, they are created differently and they have tendency to release contaminant only at a certain condition. So these kind of contaminants, due to its origins, I mean, it's already in the soil, we have a different name. For this kind of pollutants that already exist in the rock and soil, we call it geogenic pollutants. Geogenic pollutants. And one of the most, I mean, one of the most famous is arsenic lah. Okay. Apart from arsenic, aluminium also may be considered as geogenic pollutants. But the most famous is arsenic simply because it has been like an issue like in Bangladesh. Let's not talk about Bangladesh lah, because I think Bangladesh issue is very severe, but the way it happens and also the way it harms human also very similar in Malaysia. Now, I would like to discuss I mean, a little bit of the rocks in earth crust. Like I told you just now, the major source of geogenic arsenic is called arsenopyrite. I won't go into give you the full name. It's just for your general knowledge. But I encourage you to find out because why? Because what we're going to happen in Malaysia is now Malaysia, I can tell you straight away, like don't have enough money, and they want to find more source of income, either chopping down trees or maybe digging up mine lands so that they can extract the precious metal. Uh, so it won't going to happen in my time probably. It won't. It will certainly happen in your time, in which some of the places in Sarawak as well as in Pahang or somewhere maybe in Kelantan, they also still have some deposit of gold. So previously, a few years ago, I've heard that these places, they are about to be open, and if they have mining activities where they have land clearing, okay, when there is a land clearing, arsenopyrite will release the arsenic, and that comes to your food chain. So I guess this is what you need to find out lah, yeah, because I probably won't stay long enough to like get suffered by those kind of consequences, but you will. So you better find out, yeah. But currently, most of the heavy metals comes from industrialization. So these are the example lah. Combustion of fossil fuel. I guess I don't need to explain so much. Like you may have learned from other subjects like air pollution. The other thing is the use of fertilizer. Now, most of you don't know that fertilizer either comes from human waste. So if it's from human waste, then there's a source of copper and zinc. However, if it's from a mine fertilizer like rock phosphate is mine, and they can contain either arsenic or cadmium. And lastly, pesticide is made from a lot of toxic elements like mercury used to be one, but because of the toxic effect, they are no longer being used. But here's the thing: no matter what kind of contaminants they use, and similarly to organic pollutants, it will migrate into the food chain. Now, although the way they are migrating is quite different, but it will end up to humans. So if you still remember, for organic, they will be migrated through the fatty tissues of all organisms, starting from microbe, and then they'll build up in the so-called the fish or whatever, and they end up in humans. Um, for organic chemicals, it depends because, like I told you just now, most of them they are metals, right? And if we're talking about metals, usually metals will not be strongly attached to fatty tissues, but it will attach to the proteins. So inorganic chemicals lah, for heavy metals or whatever the metals contaminants that we're discussing right now, they will attach to the protein structure, like your muscles, your muscle tissues, and probably the hair tissue as well. So whatever made from proteins, they usually associated with the accumulation of heavy metal. So here, what will happen? These pollutants might going to end up in air. So if it's in the air, how does it accumulate in the plants? So it needs to end up in the soil first. And in the soil, it is dissolved by water, groundwater, which will be absorbed by plants. So it can be absorbed through the plants once it is dissolved in water. Will it be absorbed through the air particulates? Most likely not. So if you want to go through the plants, it will be through the soil, and it will be converted first into aqueous soluble phase, and it will be absorbed by plants. However, plants is not the only way it will come to humans. It may come through birds and also fish. So before fish and birds, birds, of course, they fly in the air. So whatever the particles suspended in the air, if it's breathed in by the birds, it will be accumulated lah. Inhalation. So from air to birds, the best name to describe this migration is inhalation, because they need to breathe. So once they breathe, the particulate will end up in their lungs, and from their lungs is transferred into their bloodstream, and after that into their muscle tissue. Now, on the other hand, when it comes to water, like I said, soil, if it's depositing all those contaminated air particles, they were going to deposit it, and then they're probably going to be eroded or leached from the soil into water stream, and then it may start from fresh water and ends up in marine or seawater. So what happened to the fish is that, of course lah, whatever the dissolved phase, whatever the metals that are dissolved, they will be accumulated in the fish muscle tissue. Now that can be said for a few elements lah. Now for information, whatever the elements that I've shown you earlier, not all of them accumulated in fish. I'm taking example lah. For Malaysian fish that are caught in Peninsular Malaysia, most of them, they are contaminated with, number one, cadmium. That is a surprising thing, because if you look at other research in other countries, their fish is primarily contaminated with mercury. But in Malaysia, the primary contaminant in Malaysian fish is cadmium. And for the past 10 years, it is true. Now, why it is cadmium, I cannot answer why. Maybe because there is a source here, or maybe there's a tendency that Malaysian fish tends to accumulate. But I believe there's a lot of factor that we also still don't know why Malaysian fish has more cadmium than other elements. Okay, what's next? I'm not sure. Probably is lead or mercury. But no matter what kind of fish that you caught from other countries, other regions, or in Malaysia, all fishes in the world will have these three elements. It's either cadmium, lead, or mercury. The others, it depends. But it's always these three that tops the list. And that's the same with Malaysia. So you might be wondering, how come mercury ends up in fish? Well, mercury is one thing that is a concern for such a long time, because mercury, in terms of chemistry, mercury is quite unique. Not only mercury can dissolve in water and dissolve in a way that it is a Hg2 plus, is a cation. Mercury can become a cation in water. But at the same time, with some reaction with microbes in the soil, these mercury also may become organic mercury, which means Hg, the element mercury, may attach with an organic component like it methyl or ethyl group. Usually it's methyl group. So Hg attached to one methyl group or two methyl groups, and this mercury will become what we call non-polar mercury. So just now it was Hg2 plus, a cation. Cation is ionic, very polar, dissolved in water. But after reaction with bacteria or microbes, they become non-polar. So what happened? This so-called organic mercury will become a gas. So it may be volatilized, or it may accumulate in fatty tissue. So mercury is quite a trouble, because it may accumulate in the fatty tissue of the fish, or it might accumulate in their muscle. So most of the fish in the world, they are contaminated in these two ways. Whatever that happens, that accumulated in these kind of animals, if they are contaminated and they are consumed by humans, then human will going to be affected. Okay, now once again, I believe you must have encountered with these few keywords, such as bioaccumulation and biomagnification. So by definition, bioaccumulation is how it's a definition that defines how this organism in the food chain absorbs the pollutants from what they eat. So they are bioaccumulated. Now biomagnification is a different story. Biomagnification means the amount of heavy metals that they multiply or they increase in amount when moving from lower trophic to higher trophic organism. So it kind of like a build up, or the increase of concentration of the pollutants when moving up the food chain. So this, I know you don't like English, but you better get this. I mean, in your head, you have to know what does that mean, because these are the keywords that always being used when we describing the pollution in the environment. So there's no different with soil pollution as well. We are going to use these two keywords when describing the effect or the fate of these pollutants in the environment. So this is how it's going to happen and how it harms human. Now the prevention, what do we do? Of course, when we know there is a pollution happens in the environment, usually in terms of food safety, that will be the first concern. Like for example, a few years back when in Fukushima, when there's a nuclear disaster, you know what happened? Japanese people stopped eating seafood first, because they thought, okay, because the inorganic or the radionuclides, the radioactive pollutants might have spread it. It is true, it did spread it, but it is spread a little bit lah. Now, most of the food stuff coming from Fukushima, they stop eating completely because I think you also see that the the mutation that happens. Some of the flowers they mutate very differently. It's like a very strange creature. So that is why. Number one is of course lah, they will going to stop eating the food stuff. But here's the thing: if it happens in the soil, there's really not much you can do except to control the damage. Now, in this thing, if you have a control on the source of pollution, first of all, stop the pollution. Stop the source first. Because if the source is still dishing out all this pollutant, virtually there's nothing much you can do. So the first thing is to stop the pollution by eliminating or drastically reduce the release of the toxin. Now, of course, this toxin is released due to some activities, like it due to the industrialization or industrial activities that happen. So if that is a source, usually, in this case, DOE, for example, will issue a stop work order, and then straight away they stop. Okay, so they stop the source, and then what they do next, they will going to treat the pollutants. So the second point is most likely the second step to immobilize the toxin by means of soil management to prevent it from moving to food or water supply. So in this case, the toxin already released into the soil. Now you have two choices: either you remove it or you stop it from moving away. Now why do we why do we always use immobilization? That is because immobilization is said to be not too expensive. It's effective. It's not too expensive, and it can like give you instant effect. Because whenever you have the pollutants, the immediate danger is human health. So to reduce that impact, all you need to do is stop the pollutants from reaching human. So immobilization can do that. And then, well, this technique, we're going to stop the pollutants from moving away, but here's the thing, the pollutants is still there. So which means that eventually we're going to harm humans again. So that is why further treatment is needed. After immobilization, usually is follow up by the follow-up treatment techniques such as chemical treatment, physical treatment, or biological treatment. Now, the chemical treatment may be soil washing, I would say. Example of this chemical treatment is soil washing. Now, once you have immobilized the soil, you can excavate it. So move it to a factory or a plant that can physically remove the contaminants from the soil. So soil washing is one. There are many techniques actually, depending on what kind of pollutants that you're dealing. Some of them may even use what we call complexing agent. So in the soil washing technique, if you want to wash away organic pollutants, you use surfactant. Surfactant is no different than the soap molecules that you use when you wash your hands. Exactly that. Now, surfactants have a polar head and non-polar tail. Now, that is to remove organic pollutants. But what about inorganic pollutants? Those that have like metal base. We don't use surfactants, we don't use surfactants, but rather we use another kind of molecule. We call it complexing agent. So remember, soil washing also is not just one technique. It also may have several techniques depending on what you want to remove. So to remove inorganic or what we call metal-based contaminant, usually we use complexing agent. I'm sure you have heard this chemical before. It's called EDTA. Now, EDTA has been used to wash away heavy metals from the soil. Okay, so that's chemical. Now, what about physical? So physical technique can be without using any chemicals, so there's no chemical change. Usually, the physical technique will involve the use of energy. And I think energy probably is the one that I can come up right now. Okay. Now, in physical treatment, again, a bit of reference, a bit of revision from your organic side. Previously, the physical technique uses heat treatment to extract the organic pollutant, because organic pollutants previously we know some of them very volatile. So when you heat it, they will remove away without any change of chemical structure. And also, when you have extremely high temperature, it might going to burn off everything. Now, in this case, how do you treat the metal pollutants? It's also the same. You also use high temperature, but this time we know metal cannot volatilize, except, I think I just told you, there's only one metal that can volatilize, and that is mercury. Okay, so don't think that mercury cannot be removed. It can be removed. And then one technique is by volatilization. So same thing, if a soil have mercury and that mercury can be volatilized, you just heat it a little bit so that the mercury can be like distilled off. Yeah, that can be done. In fact, this kind of technique of volatilized mercury has been used in extracting gold. If you have seen documentary lah, the gold extraction in Indonesia, exactly what they do. They use mercury, extract gold, and then they boil off the mercury. There you go, you got your gold. There's another technique also incineration, because metals, if it's trapped in the soil. Now, when the soil happens to have a high content of sand, for example, silica, and you can use this technique. Okay, so the sand, if you heat it high enough to, I think, 900 degrees. If you heat it to 900 degrees, the sand will going to turn into glass. So this is another technique. You use the sand, the silica already in the soil. If it's heated high enough, it will melt, and then it will coat and then encapsulate. It will coat the entire and surround the entire heavy metals. And once it's cooled down, the heavy metal is surrounded by the glass, and then you don't have the risk of leaching. So it's the same technique, but the explanation is a bit different than the one of organic pollutants. And of course, you can always use the biological remediation. And for your information, most of the time we use biological remediation because it's cheap. Either use bacteria, which is cheap, or you use tree that you can plant later on. So I think reducing the soil application, I think I jumped the gun again. So let's go through the points lah, yeah. So reduce the use of the items or the activities that can cause the pollution. So I think I've explained this already. Skip. Immobilizing. Oh, I think this one I missed one thing. Just now when I say immobilization, you still remember last time where you have organoclay. So organoclay, they have the organic part. And with that organic part, it can absorb. It will attach to the oils, the oily pollutants, so they will immobilize. However, the technique of immobilizing heavy metals or metal-based contaminants is a bit different. Yeah, we no longer use organoclay. Now, for immobilizing metals, you either increase the pH or decrease the pH. Because in this case, if you have cations, cation pollutants like cadmium 2 plus, lead 2 plus, or maybe even mercury, you can actually increase the pH. So when the pH is high enough, these metals will turn into metal hydroxide, and then finally metal carbonate. Now, most of the metal carbonates, they are insoluble, except earth alkaline or alkaline or earth alkaline metals. What I'm saying right here is actually what you did learn in diploma or matrix. I hope you still remember. There's one experiment where you did in diploma and matrix where you mix a certain cation with a certain anion, and then it has precipitate. Exactly the same technique where we're using here, which is why another good candidate for immobilizing heavy metal apart from increasing the pH is by using phosphate. Now, if you still remember, phosphate is this one anions that can immobilize lead effectively. Okay, so lead sulfate is not soluble, but the most the I mean the version, I mean the compound of lead that is the least soluble is coming from phosphate. So you can see in the remediation technique to address metal contaminated soil, they also use phosphate, and they love to use phosphate compared to high pH because phosphate is a fertilizer. If anything that this phosphate is not being used, it will not going to harm the environment except excessive because phosphate also, you also know, for it also may cause eutrophication. But if used in the right dosage, in the right condition, not excessively a lot of phosphate, this may help reduce the solubility of heavy metals, and at the same time phosphate also can be used as a fertilizer. So there you go. Immobilization for inorganic contaminants. We don't use organoclay. Listen carefully. We don't use organoclay for inorganic contaminants, but rather we use phosphate or just any alkali material. So in this case, if you say any alkali material, usually they use limestone or phosphate fertilizer.